Hi everyone. In this video, we're going to get a chance to start solving equations that involve some of the structures you've been seeing recently. So the objectives for the video then, to introduce square root as an inverse operation for squaring. And then second, to introduce the fundamental theorem of algebra as a rationale for giving two answers to x squared equations. As that name suggests, the fundamental theorem of algebra is really at the core of what kind of happens after Algebra 1. It's a pretty big deal. So let's get started. First of all, a little bit of a recall. Recall from the last video and probably from previous course what that means. That's the square root of 36, and you're asking what number times itself gets you 36. And 36 was a nice number. We would end up with 6, we thought. But what I tried to do in the last video is to introduce that not just as the square root being a thing, but actually an operation that you perform on 36. You take that 36, you do something called square root, and it's a pretty complicated explanation, but it's an operation. We need you to think about it that way. Another thing I want you to remember before we get too far into this is when we were graphing y equals x squared, we noticed something. We noticed that when we were graphing y equals x squared, we had to plug in x values we chose. We chose to plug in 2, and when we squared 2, we got 4. But I want you to notice that we also, at some point, plugged in -2 for x squared and got the same result as 4. So when you're doing order of operations and you're evaluating expressions, you don't necessarily think too much about that. And in the video, it ended up leading to a drawing, and we kind of moved on from there. But I need you to keep that in mind as we look at our first example of solving an equation that has an x squared in it. So the directions, not too much to it, says to solve, and we know what that is. Solving an equation is to look at the equation and say, I'm going to tell you the value of x that would make this thing true. And you might do this logically. You might look at that and say, so if some number squared equals 36, you might know that number would be 6 and be done with it. But I want you to think about the inverse operation thing, where a square root is an operation, and it can be an inverse operation. It's the inverse operation for squaring. So if we're thinking about it as, what can I do to both sides of this equation to get x by itself, so that I'll know what x is, it's whatever the inverse of squaring is, and that is square rooting. So square rooting is an operation. It has to be balanced. You do it to both sides of the equation. So you're square rooting on the left-hand side so you can get x by itself, and you're square rooting on the right-hand side for balance sake. So you get a new true equivalent equation. Those guys cancel. That's what inverse operations do. And you would be left with x on that side and whatever the square root of 36 is on the other side. Looking up here, you think, well, the square root of 36 is 6, so let's be done with it. There it is. Our answer is x equals 6. And that falls in line pretty well with almost every single equation we've solved in chapter 1. You're expecting to get an answer for x, maybe all reals, maybe no solutions. But if you get an answer for x, you're usually satisfied. But isn't x equals -6 also a value of x that makes this thing true? Like back when we were thinking about this logically and we said, so some number got squared and you got 36, up here we've got evidence that the number that you squared could have actually been a negative number and it would have ended up being positive 36. The fundamental theorem of algebra is going to help us when we're going to solve equations to take into account that this equation, x squared equals 36, has the value of x that we found by doing an operation, but also has a second value that we thought about logically. And that's because the fundamental theorem of algebra, for as big a deal it is, it's a very simple thing. It says the exponent in the equation, and I should probably say the biggest exponent in the equation, tells you the number of solutions that an equation has. So if we're on our toes over here and we're looking to solve x squared equals 36, and you have in the back of your mind the fundamental theorem of algebra, you think, I'm going to find 2 answers. And if you do just find x equals 6, you think, wait a second, I was supposed to find 2 answers. And admittedly, sometimes 2 answers is a little bit of a stretch, but for this class, 2 answers is what we want to do. So how are we going to handle it then? We are going to be determined that when we take the square root of both sides, you have to think of the positive square root or the negative square root. When we are handed a square root symbol, it's just asking for the square root, the positive square root. But if you know there's 2 answers, square rooting in this case is actually a little bit more of a shortcut than we think. But the way we can handle that and be thorough about it is when I square root, I'm going to write a plus or minus. And that's going to lead to over here. Now the square root of x squared is still going to be x, but on the right-hand side, that's the way to take care of the 6 and the -6. So let's keep that in mind as we move forward. Second example, in some ways very similar, in some ways a little bit different, a little bit more complicated. We're going to solve x squared minus 2 equals 2. It's an x squared equation. We might be anxious to try to hurry up and use the square root because that's our new tool and our new toy we just figured out. And there it says right there, introduce square root. But I want you to keep in mind that when you solve an equation, maybe the first time you started solving equations it was through practice, but I've been trying to make it loud and clear in this course. When you're unraveling x and you're unwinding an equation, you have to work in the opposite order of PEMDAS. So all this math happened to x, and as a result, 2 came out. But if you wanted to find out what you started with, you have to take the layers off backwards. So if this got squared and then we had 2 subtracted to result in 2, we have to undo this outer layer first, and then we can undo this layer. So we apply inverse operations in the opposite order of PEMDAS. And we've been making it pretty clear that that later term is the last thing that happens in PEMDAS. So we're going to use an inverse operation for minus 2, which is plus 2. It gets us the equivalent equation, x squared plus 4. Now we're excited because we can use this new tool of square root, but you got to keep in mind the fundamental theorem of algebra. The fundamental theorem of algebra says even this simple little equation, x squared equals 4, that should have 2 answers. So when you square root, don't forget to go plus or minus, and then you can get that your answer is on this side you get x because of inverse operations, and on this side you get whatever the square root of 4 is, the positive version and the negative version. You get 2 answers. Now, I take a time here to maybe do like a little bonus objective, and that is to try to make a connection between what we were doing last, or one of these recent videos about parabolas and this fundamental theorem of algebra. 2 answers to x squared equations is actually connected to our parabola work. I just want to take a little second and point that out. So here was a example that we did in a previous video. We had graphed an expression, which actually is very much in play right now, x squared minus 2. And at the time, we plugged in a bunch of x's, got out some y's. And we did just get some symmetry. We figured out that the same y values came out twice. Well, in that case, if we look at it really closely here, there were, in the table and in the graph, we could see that there were 2 times that x squared minus 2 kicked out a result of 2. Right here is where x squared minus 2 resulted in 2. And right here is where x squared minus 2 resulted in 2. And those 2 x values that went in at that point are the 2 and the negative 2. So it shouldn't surprise us too much that x squared minus 2 equals 2 for 2 different x values. Positive 2 can go in or negative 2 can go in. And that's also why this parabola is happening the way it is, because if you look at output of 2, and you drew a line there, you can actually see there's 2 x values where it's happening. So it's all connected. That's a little bit more than you need right now. We're going to concentrate on the algebra, the equation solving right now. So if the takeaway from this video ought to be the following. You got square root as an inverse operation for squaring, and the fundamental theorem of algebra says get 2 answers if you're using a square root.